All right, I'm going to show you how to do some of these problems on this density worksheet. Some of them are similar to what you did before, so the ones that I'm not doing, I'm going to expect you to at least submit answers to. You can do this on paper, or if you just want to print out the worksheet and then take a picture or scan it, however you can get it to me is fine. I'll be very flexible in how you turn this in. So I'm going to start looking at question number 2. So the sentence here is just giving me information. So I'm going to need that density idea, but I'm actually trying to find volume in liters, so that's my target, and I have 3.55 kilograms. So anytime you have density problems with kind of this idea of we're solving the other, you can do the equation, but as you're going to see when we get to some of these other ones, this one too, it's not as easy to do it in the equation when you have unit conversions. So I have to decide which one of these to start with. So I am going to start with the 3.55 kilograms because that's a measurement. I could measure out 3.55 kilograms and put it in a pile in front of me. This is a ratio. I can't put that pile of 11.3 in front of me. Okay. And then I'm going to, at the end, put liters because that's what I'm trying to find. So my density is given in grams. So my first step then is going to be to get kilograms to grams so that I can use the density. So density is the only thing that allows you to switch between units of mass and units of volume. So it's going to be my conversion factor. So since I have grams on top, I'm going to need grams on the bottom. The number always stays with the grams. So grams on the bottom, centimeters cubed will flip up top. Remember, this slash is the same as our straight line. It's a top and bottom. So when the 11.3 grams goes on the bottom, the centimeters cubed goes up top. I don't have to put a number with it. If it bothers you, you can put a 1, but this whole relationship is 3 sig figs. Okay. That's going to cancel my units of grams. This gives me cubic centimeters. I've got to get to liters. Anytime you have cube units to liters, you're going to use that 1 milliliter as 1 cubic centimeter. My cubic centimeters are now going to cancel. That gives me milliliters, and then I just have to get milliliters to liters. Okay. Again, liters are larger, so I'm going to put the 1 with the liter, and the 1,000, or the mill, goes with the milliliters. And then I'm just ready to calculate. So I'm going to put 3.55 times 1,000 divided by 11.3 divided by 1,000. Again, the order doesn't matter as long as you do all of the steps. I just work left to right. Not everybody does. And I'm going to have 3 sig figs because this answer or this measurement is also 3 sig figs. So my two quantities that come from measurements are both 3. Remember, these two are actually definitions in the metric system, and you wouldn't even have to enter those thousands. Just like we can cancel units if the number's the same on top and bottom, you can also cancel the same numbers. Okay. All right, question number 3 looks very similar. So I have a sentence that's telling me density. This time though, I'm trying to find mass in grams, and I have 35 cubic millimeters. So this one is actually a volume. So anytime you see a cubed or liters, milliliters, that's volume. So I'm actually starting with volume, and I need to get to mass. So again, density is going to be what allows me to convert. So I'm going to put my millimeters cubed here, and I need to end up in grams. So the only relationships we have that are cubed is centimeters cubed to milliliters. So I don't really need that for this one because I only need to get to centimeters cubed, and this is going to grams. So up here I needed it because I was going to liters. So this is just basically changing my 3-dimensional. So remember, this was my length times width times height. So I need to change each one of those dimensions. So I'm going to have millimeters to meters. So again, your base unit, meters is larger, and I need to do that 3 times because I've got to change the length, the width, and then the height. Okay. So now that I have 1, 2, 3 of these, I can cancel cubic millimeters. That gives me then meters times meters times meters, which is cubic meters. I don't have any relationships with cubic meters. I'm still trying to get to cubic centimeters. So 1 meter is 100 centimeters, and that only cancels this one, so I have to do that one 3 times as well. So that cancels my other 2 meters. That gives me centimeters cubed because I have 1, 2, 3 centimeters. So this time the gram part's going to go on the top, and the cubic centimeter part is going to go on the bottom. So this 3 cancels my 1, 2, 3 centimeters that I have here. And then again, I'm just going to divide all of these, multiply, 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 multiply. So there's a lot of steps in this one, but you eventually will get 0.28 grams. And again, if you want to put the 0 there. 2 sig figs because of this one. All of these are metric relationships up to here, and this one is 3 sig figs. All right, then number 4, I have 37 kilograms. I'm trying to find density, and 350 liters. So I have my mass and my volume. So I am going to set this up as a bridge problem, but kind of plugging in the equation. So my mass over volume, so I'm going to put the mass on the top, the volume on the bottom. And then density is either grams per cubic centimeter or grams per milliliter. So since this one is already in liters, I'm going to go ahead and go grams per milliliter. So I'm going to convert kilograms first to grams. Remember, kilo is king. There's only 1 king and 1,000 subjects, so that's going to cancel my kilograms. I don't have to do anything else with grams because that's what I'm trying to find. And then I'm going to put liters on the top and milliliters on the bottom. So liters are larger and 1,000 milliliters there. So I'm going to cancel my unit of liters. And that gives me what I'm trying to find, grams over milliliters. So I am ready to calculate. Again, notice those thousands will actually cancel out. And really you can just divide 37.0 divided by 350 to get 0.11 grams per milliliter. So this number of mass is 3 sig figs, but my volume is only 2 sig figs. So when I multiply, I have to do least amount, which is 2. All right, I'd like you to try on your own questions 1, 5, 6, 7, and 8. All right, for question number 9, we have it all in one question. I want to know density again, so as soon as I'm thinking density, I kind of have to think of my equation, D equals m over v. And I have a cube that has a length of 6.7. So what makes something a cube is all of these are the same dimension. So really the length, the width, and the height are all 6.7 centimeters, and my mass is 850 milligrams. So again, density has to be grams over centimeters cubed. So I'm going to put my 850 milligrams on the top. And then I'm going to put my 6.7 centimeters on the bottom. Now, this is my length, width, and height, which is going to get me volume. I'm going to leave these blank because these are measurements. They're not conversion factors, so I don't have to have anything on top. So at this point, I have centimeters times centimeters times centimeters, which is my cubic centimeters, so I don't have to do anything else there. But this one is in milligrams, so I've got to get milligrams to grams to match up this unit. So grams are going to be larger, and then 1,000 milligrams in a gram. And my milligram units cancel. Grams over cubic centimeters is what I'm left with. So I'm going to do 850 divided by 6.7 divided by 6.7 divided by 6.7. Or you can use on the calculator. If you don't want to do that, you can do 850 divided by 6.7, your y to the x key or x to the y key, or some calculators have a caret button, y to the x 3. Okay, and then I just have to divide that by 1,000 to get my 0.0028. Again, both of these are 2 sig figs, the 6.7 and the 850, so no choice there. All right, and the last question 10 is a word problem. So you'll see there's a lot more text there. So again, I have a sentence that's telling me something about aluminum's density. I have a mass of 12.06. What volume in liters is what I'm trying to find. Must be put into a mold that makes 24 cans at a time. So industrial processes, so a foundry like at Shepherd and Myers, they have to know how much material goes into each mold. That helps them with inventory. It helps them with the cost. So we have all of these numbers. So ultimately what determines how much aluminum we're going to need is how big the mold is. And the mold makes 24 cans. So I'm starting with 24 cans. And I want to end up with liters. So what I know about a can is a can is the same as 1 can. Has a mass of 12.06 grams, so that gets rid of my unit of cans. I then have grams, which I can use density to get rid of that. And that gives me cubic centimeters. Again, if you don't like that, you can put a 1 in, but this whole relationship is 4 sig figs. So I've got to get centimeters cubed to liters, so the only way I can do that is cubic centimeters and milliliters. Those are going to cancel, and then milliliters to liters. So milliliters has to go on the bottom, liters on the top. 1 liter is larger, 1,000 milliliters. Okay. And then we're just ready to multiply on the top. 24 times 12.06 divided by 2.151 divided by 1,000. Again, my only unit left is liters. For sig figs, I only have to check these two numbers. So these are the two that come from measurements. 24 is considered a counted number. I can't have 24.0625 cans. I can only have 24 cans or 25 cans. So that's not considered sig figs. And when you multiply that all out, that answer is 0.1346 liters. Okay, there is going to be a place in Blend for you to submit your answers. You can submit them on a Google Doc. You can submit them as a picture, as a scanned document, whatever you need to submit that. Thanks. Hope you're doing well.